Good morning and welcome to the Science Magazine program. Unified Aerospace Management and Applied Technology Works and Achievements of CSIR-NAL National Aerospace Laboratories, Bangaluru. Please listen to an interview with Dr. Abhay A. Pashilkar, Director CSIR-NAL Bangaluru. Interviewer is Manoj Mayankar.
It's a pleasure and a privilege to welcome Dr. Abhay A. Pashilkar, Director, CSIR, National Aerospace Laboratories, NAL, to the studios of Akashvani in New Delhi. Welcome to the studio.
Thank you.
The purpose of this little conversation that we are planning to have with you is three-pronged. A, what brings you to Delhi? B, because for us, the name NAL is extremely rare because it's slightly out of the way. We interview people from many other institutions regularly, but this area is something that one is more curious about to know a little bit more. I'd like to begin with your visit to, as I welcome you on behalf of this city as well. What exactly brings you to Delhi?
As you know, Delhi is the headquarters of the CSIR and NAL is part of the CSIR family of laboratories. We come from down south, from the city of Bangaluru, and aerospace, as you know very well, is such an important part of nation's overall growth and power progress. And you have seen recently how air power dominates all others when it comes to not only civilian, areas, but also military areas. And the National Aerospace Laboratories, or NAL, is essentially only civilian lab in the country working on all aspects of both aeronautics, that is flight within the air, within the atmosphere, as well as space to an extent. And as you asked why I'm Delhi, so apart from being our headquarters,
I'm sure it's a special occasion.
Yes, that is true. So we are conducting this seminar on unified air traffic management and allied technologies. We believe India is on the cusp of next level of growth, and it requires us to be able to manage our air traffic, not only the traditionally civilian aircraft, military aircrafts and so on, which are handled by various agencies, but also increasingly drones. India has set a goal for itself to be the drone hub by 2030. It has military applications as well. So therefore, we need to make sure that the airspace management, because just like highways and roadways and railways have a signaling system and overall traffic management system, so even the airways, or rather I should say airways is more like what you call in Akashvani, but I meant the path in which the aircraft will fly, whether it is manned or drones and so on, both civil and military. That entire system has to be managed, the traffic has to be managed there. So, and it effectively becomes unified in the sense that you have different mix of vehicles now, how to permit them to fly in that same airspace. That is the challenge we are trying to address through this workshop.
Dr. Pashilkar, that has partially answered my curiosity, but for a young person who's listening to the program, he or she would certainly, formally want to understand the little difference between, commonly heard terms, but not used extensively, aviation, aeronautics, and aerospace. Do they overlap? Do they separate at places?
So normally a common man, they see the results of the development, research, the products that we use daily, be it drones, or we all travel in civilian aircraft. Many of us do that on a regular basis nowadays, or we enjoy air shows where military aircraft conduct their operations. So essentially what requires to be done, as I said, is to manage when these aircrafts are flying that do not, for example, collide with each other, that they are able to reach from source to destination in a very efficient way. They don't have to take diversions, which are for various other maybe reasons and so on. As we saw during recent wars, there would be areas where you are not allowed to enter. There are military areas again. So how do you manage this complex aerospace where certain restrictions are there, certain no-fly zones are there? That really is the crux of this particular workshop, and this is part of aviation. So we come from National Aerospace Laboratories, we talk of aircraft, we talk of technologies, but there is a bigger umbrella which covers everything, including airlines, which operate such aircraft. Tomorrow, drones or agriculture, people associated with agriculture would like to operate drones, are already operating drones in the country. So this entire thing, which includes flight within the the atmosphere, which is what we work also, and ISRO activities, which is outside the atmosphere. We have satellites and all which are outside of that, or we have Chandrayaan, Gaganyaan. So that encompasses both aeronautics and space. So that's where the aerospace term comes. And we work majorly in everything to do within the atmosphere, and to an extent we support ISRO and its activities in outside the atmosphere.
Now that we have understood the meaning of aerospace to quite an extent, I'd now like to learn a little more about the National Aerospace Laboratories situated in Bangaluru. You are the director there. We'd like to know, in a nutshell, the structure, its various branches, its various functions. Somebody who'd like to know from a distance.
So the National Aerospace Laboratories is one among many of the CSIR labs, and as I said, it is the only one focused on aerospace and civilian laboratory to that extent. So we come under the Ministry of Science and Technology, and therefore we do innovation in all areas of aerospace. We, for example, historically we support many of the activities of DRDO, the ISRO, and in recent years we have been primarily working in civil aviation for almost maybe 30. So out of the 65 years that we are in existence since 1959, we have primarily started off as a testing establishment to support DRDO and ISRO. Then later on, certain very critical technologies like LCA Tejas, the fly-by-wire flight controls of that aircraft were developed primarily at the NAL Work Center with joint work from HAL and the DRDO. And the carbon fiber technology is another major piece of technology which NAL was the starting point for bringing in carbon fibers in place of metal, which are now, it's used not only for aircraft but also for other things like lightweight, sports goods and so on. And lately, as I said, more into civil aircraft because we are the only civilian such organization. So this has been our trajectory. Initially as a major provider of testing facilities to all aerospace organizations in the country. Then later on as a technology development partner for many of the programs of DRDO and ISRO. And in the recent past, more so in the civil aviation sector for design development of civil aircraft in this country.
That brings back memories of Dr. S.R. Valluri, the eminent scientist. I'd like you to just, briefly let our listeners know something about his greatness, tenacity, his vision.
So Dr. Valluri happened to be the second director of National Aerospace Laboratories, and he had a very long tenure of almost 19 years. And he was in many ways, apart from the first director, he was the one who really realized the initial vision of National Aerospace Laboratories during his long tenure. As I mentioned, many of the testing facilities, including some unique ones like full-scale fatigue testing and the various wind tunnels that were envisioned before he joined, all those got realized. We also have in the power plant side, engine side, we have lots of testing facilities which got developed. We have established by the time systems division, which was assisting in various aspects related to electronic systems as well as to an extent mechanical systems. So in other words, he really set the stage for NAL to shine in those years that he was the director.
Dr. Pashilkar, you mentioned the word wind tunnel testing, I think at least 3 times. Is that really important? How important is it?
That is true. It is clearly very important because anything that flies in the air or even in close to space has to encounter resistance of air. And therefore, when we design such vehicles, we always use the word aerodynamic shaping. Even the, Formula 1 cars have a certain shape. All of that is because as the speeds go up, you tend to encounter more of air resistance compared to, let's say, even ground resistance and things like that. Of course, which aircraft which flies, it is entirely air resistance and so on. So this process of testing requires us to ensure that the shape that we are using, whether it is for low speed or high speed flight, today we have now hypersonic flight, which is more than 5 times the speed of sound. And those missiles are now famous everywhere due to all the wars that are going on. So when you look at the range of speeds which are starting from less than the speed of sound to slow speed aircraft to close to speed of sound and beyond speed of sound, supersonic as we call it, and then hypersonic, which is like more than 4 to 5 times the speed of sound. This entire range we need to shape the vehicle depending on which range of speeds it is flying. And that requires us to use either computational methods or to actually the final verification is always done by taking a scaled down down model of the vehicle. So the scaled down version of the vehicle is put inside a tunnel, and that's why it is the wind tunnel. And obviously it is a physical tunnel, and you blow air on it in a very controlled, regulated manner at the precise speeds at which you would like to test it. And then you determine how the aerodynamic forces and the moments are coming upon to the vehicle. And anybody who wishes to control such a vehicle needs to know what the air is doing to that vehicle. So that's really the very first step. There is another reason why these things are important to be done in the country, because today when we want on the military side an element of surprise, so you do not want the adversary to know what type of vehicle, what are its capabilities. If you do not test it in the country, you are then forced to go abroad and test it in their facilities, somebody's facilities, and thereby your data and your geometry, everything is exposed. And therefore there is a strategic reason for vehicles which are clearly in the military domain that we should have the indigenous capability to test them as well. So that is how these testing facilities were developed in the country. And even if you look at civil aircraft or commercial aircraft, obviously those aircraft also, why would you like to reveal the performance of your vehicle to anybody else who has commercial interest in selling their vehicles? So in all respects, therefore, the shape and the nature of that vehicle and what characteristics it has got, it is best kept as a trade secret or as a proprietary information with yourselves as a country in general, both for civil and military. And that is where the importance of having our own testing facilities lies. And that's where NAL started its journey and continues to provide that kind of support to all the aerospace organizations. In fact, I should say that you name any vehicle which flies designed and developed within the country, somewhere or the other it has graduated out of our wind tunnel, especially up to 4 times the speed of sound. All those vehicles are tested at NAL.
But forgive my little silly curiosity. I'm looking at the word space in the term aerospace, and that leads me to my next question. We talked about air resistance till a certain height where aircraft fly. Is there some element of some different kind of resistance in outer space? And is any testing done for that, for rockets?
Well, certainly rockets and launch vehicles transition from within the atmosphere to outside. So clearly when they are within that range, they will face all the air resistance as we discussed, and all other associated data needs to be collected. Also nowadays, if you see, there is a lot of emphasis on reuse of vehicles. You have seen that in the American new rockets which Elon Musk and others are developing. India also in the space ISRO is developing such reusable launch vehicles, and it is not only while going out of the atmosphere, they will now come back into the atmosphere, which means that essentially they will come in at fairly high speeds and encounter the rarefied parts of the outside atmosphere at those speeds. And in those conditions, you end up having effectively a very high temperature plasma effectively sitting on the leading edge or on the front part of that. And that is why you see the kind of shapes that you see for the space shuttle. They're very different from a typical aircraft, for example, or the space return capsule through which all our astronauts return back from space. So those special shapes are required to protect the inhabitants inside, not only from the forces, but also from the very high temperatures there on the skin. So very special materials are required. So those kinds of testing also becomes important when we are talking of, as you said, little bit on the edges of the atmosphere, but not entirely into, the free space.
In free space, there's no issue as such.
Yes, that is true.
One question that anyone listening to us would be curious about: what are the kind of careers available at NAL? At what level do people enter? And
so we have typically, in fact, not only NAL, but many of CSIR labs are currently in the process of recruitment. And of course, now the last dates are all over. But generally speaking, at NAL, since I mentioned to you that primarily we are dealing with all the major aspects of vehicle. So typically anything which flies requires a structure. So you need engineers in that field. Aerodynamics we have already spoken about. So you need specialists who understand fluid dynamics and aerodynamics in different speed ranges. You would of course need people who understand engines, for example. That also we spoke a little bit about. Apart from that, what is now becoming so important is, in terms of both cost and the features, is the systems on board the aircraft. whether it is electronic, avionics, we call it avionics, aviation electronics is a combination of that.
And that applies to drones as well.
Everywhere, avionics is taking precedence. We talk of radar, we talk of stealth, we talk of all of that is related to electromagnetics and avionics and things. So that is one other major system. And then you have the mechanical systems. You see many things moving in the aircraft. You see the landing gear coming down. You see some things. If you see the wing when it's taking off or landing, you see parts of it moving around, and the aircraft is controlled by moving some surfaces up or down. So all of those are broadly mechanical systems. So these are the 5 major entities or the domains or the themes which are required to make typical aircraft work, which we are so familiar with. Fixed wing. Then you have the rotary wing aircraft where you have helicopters, and the drones also, many of them fall in that class where you have a huge amount of rotors which are spinning around and things like that. So each aircraft has different category and a different behavior. So when you look at in the totality of all this, you find that almost so every major discipline of engineering is somewhere or the other, and in some cases even some sciences get involved because the materials, for example, so you have material science. So we have within NAL 5 clusters. So one is the aerothermal cluster, which is both aerodynamics and I said high temperatures, thermal part. So both engines, internal aerodynamics, external, all of that encompasses aerothermal cluster. Then you have, I said, the materials cluster. Materials are so important for everything that we do, whether it is semiconductors, although we do not directly work, but broadly speaking, materials are everywhere, used in all aspects of engineering. Then you have the systems cluster, which I mentioned to you, that systems are also so important, whether it's avionics, electrical, and so on. And then you have the structural cluster itself. So basically the structural cluster, the aerothermal cluster, the materials cluster, and the structural cluster, we work with composites, which we mentioned. We work with metallic materials, which is another important part of the aircraft, and so on. So these are the major clusters. And there is another cluster, which is the aircraft cluster, which is, we are talking not about the subject matter, but the product side of things. We also make, like I said, civil air. So these are the 5 clusters that we deal with. When you start looking at the details, you find that if you look at our advertisements, you will find that almost every branch of engineering, mechanical, aeronautics, related to thermal engineering or related to materials engineering, you will find one or the other post there. Basically, an aircraft is a multidisciplinary system, and many of these posts are at entry level. So whereas typically scientists C, as we call it in our system. So these are people who typically have a master's degree. They are specialized in some one or the other of these areas, and then they grow in the organization. They learn the skill set. They learn on the job. They get trained. They are sent out for training in various ways, and then they grow into the system. So they then become specialists in one or the other areas, like I said, broadly covering aircrafts. They may also do fundamental research at the materials level or at some very, very specialized process level. I want to know how to weld certain things. I want to, like I said, any new material has come in. I want to use it and produce aircraft structures. Stealth technology is very important, more so nowadays. You have heard of the B-2 bomber, which flew recently. Things like that. So whatever is relevant to the needs of the country in the military domain or the civilian domain, we tend to build the capacity, the human capacity in that respect. So largely we have people who come in at entry level, like I mentioned, but we do also have time to time advertisements for people who come at a lateral level, because sometimes we do need to, you said stealth technology, for example, it came into NAL not from entry level. These are technologies which require a certain level of maturity, and you need somebody with the right experience to come in, set up a center of excellence, for example, and then they are able to attract talented people to come at maybe lower levels, even entry levels, and build up very quickly the capability of the laboratory or in order to support national interest. So that's typically how we work, and everything is out in the public domain. We do have a website, so anything that we advertise for, whether it's permanent posts, which are scientists, or we also have technical cadre, which is typically diploma holders. Then next to that we have ITI category. We need all of these people. You can imagine if you have to do testing or design, you need all kinds of skill sets. So at all levels we recruit. We also recruit project-based manpower quite a bit, which is meant so youngsters come in who get direct exposure to live projects, and that helps them in confidence as well as knowledge, which you would otherwise not find anywhere, even if you wish to go abroad, because many of these are very, very, like I said, strategic in nature or have a certain IP or intellectual property associated, and people will not just like that expose you to their intellectual property. So all these opportunities are available to young engineers if they keep a watch out for when we put out these advertisements, either as temporary project assistants or as regular scientists from time to time.
Dr. Abhay A. Pashilkar, it was an extremely stimulating stimulating conversation with you. At the outset, I mentioned the purpose of this interview is three-pronged. We touched 2 points. The last one could be treated in a lighter vein. I want to know if the director of National Aerospace Laboratories knows how to fly an aircraft.
Well, I started my career. It's a very good question. I should say that. I started my career as somebody who was working in building flight simulators. So I can say that yes, I can fly these LCA or the SARAS in the simulator. I do not hold the commercial or other pilot license. We do have people who potentially can fly, or we should encourage them to fly. And we would love to have youngsters, especially who are interested. In fact, we would encourage them, like I said, as part of their training, because if we have any ambition to make civil aircraft in this country ourselves, definitely a good designer should also be a good operator. Dimension of input coming to inform their design.
Dr. Pashilkar, thank you very much for sparing time for our listeners and coming over to our studios.
It's my pleasure, and thank you again.
Thank you.
You were listening to an interview with Dr. Abhay A. Pashilkar, Director CSIR-NAL Bangaluru, on Unified Aerospace Management and Applied Technology, Works and Achievements of CSIR-NAL. Interviewer was Manoj Mayankar. Narrated by Neelam Malkania and produced by Dilip Jha. This broadcast came to you from Indraprasth channel of Akashvani, Delhi.